Have you noticed how it feels like we're hearing about earthquakes more and more often? It's not just you. In today's video, we're going to dive deep into why it seems like our planet is getting a bit more shaky. Let's break down the science behind the recent rise in earthquake activity as of our October 2025 update. So, first things first, what exactly is an earthquake? Imagine the Earth's surface isn't one solid piece but a bunch of giant, interlocking puzzle pieces called tectonic plates. These plates are constantly, slowly moving around on a layer of semi-molten rock called the mantle. Most of the time they glide past each other smoothly, but sometimes the edges get stuck. Pressure builds up over years, decades, even centuries. When that pressure finally becomes too much, the plates suddenly slip, releasing a massive amount of energy in the form of seismic waves. That's what we feel as an earthquake. Now for the big question. Are earthquakes actually happening more often? This is where it gets interesting. Seismologists, the scientists who study earthquakes, generally agree that the total number of major earthquakes globally remains relatively stable over long periods. The Earth has its own rhythm. However, what has changed dramatically is our ability to detect them. We now have a global network of thousands of highly sensitive seismographs. These instruments can pick up tiny tremors in the most remote corners of the world, quakes that would have gone completely unnoticed just a few decades ago. So part of the increase is actually an increase in our awareness and our technological skill. It's like suddenly having super hearing. You're going to notice a lot more noise even if the overall volume hasn't changed. But that's not the whole story. While the global average for major quakes is steady, we are seeing an increase in seismic activity in specific regions, and a lot of this is linked to human activity. This is called induced seismicity. One of the biggest culprits is wastewater disposal from oil and gas extraction, particularly through fracking. The process involves injecting high-pressure liquid deep underground. This can increase pressure in underground faults, essentially lubricating them and making it easier for them to slip. Think of it like an air hockey table. When the air is off, the puck doesn't move easily. Turn the air on and it glides with the slightest touch. This process has been linked to swarms of small to moderate earthquakes in places that historically had very few, like Oklahoma and Texas. Another human factor is the construction of massive dams and reservoirs. The sheer weight of billions of tons of water can put immense stress on the Earth's crust underneath. This added pressure can be enough to trigger earthquakes on pre-existing faults. This has been documented near large dams all around the world. We're essentially changing the stress balance of the ground beneath our feet. Then, we have the long-term, slow-moving giant, climate change. The connection here is a bit more complex, but it's a growing area of scientific research. As massive glaciers and ice sheets melt, a tremendous weight is lifted off the Earth's crust. Think about pressing down on a memory foam mattress and then lifting your hand. The foam slowly rebounds. The Earth's crust does something similar, a process called isostatic rebound. This slow rising of the land can alter the stresses on tectonic plates and faults, potentially leading to more frequent earthquakes in those regions like Greenland and Alaska. While this is a slow process, the accelerating rate of ice melt means we could see its seismic effects become more pronounced in the coming decades. So we have this combination of factors. Better detection means we're recording more quakes than ever before. At the same time, human activities like wastewater injection and dam building are creating new seismic hotspots. And on top of it all, the long-term effects of climate change are starting to alter the stress on the planet's crust. It's a complex picture, but it explains why the ground seems a little less stable these days. So what does this mean for us? First, it highlights the importance of earthquake-resistant construction, especially in high-risk areas. Building codes that account for seismic activity save lives, period. Second, it means we need smarter, more sustainable management of our natural resources to minimize induced seismicity. And third, it's yet another reason why tackling climate change is so critical. The interconnectedness of our planet as systems is incredible. What we do to the atmosphere can eventually be felt deep within the Earth's crust. It's not about being scared. It's about being informed and prepared. Understanding the science helps us build a safer, more resilient future. The Earth is a dynamic living planet, and these shifts, both natural and human-induced, are a part of its ongoing story. By studying them, we learn not only about the planet, but about our own impact on it. Thanks so much for watching. I hope this cleared things up and gave you a new perspective on the news. If you found this video helpful, please give it a thumbs up and hit that subscribe button for more deep dives into the world around us. Let me know your thoughts in the comments below. Stay curious, and I'll see you in the next video.